Good morning, my dear children. I hope all of you are fine. In the last class, we have discussed about Chapter 5, or we have started Chapter 5 in the last class. What we have discussed? About Euclid's axiom, definition and postulates, and then the name of the chapter was Introduction to Euclid's Geometry, and we learned what Euclid's definition, postulates, axioms and postulates. Clear? So today we are going to solve exercise 5.1. Okay, let's start the class. Exercise 5.1. First question. What is the first question? That which of the following statements are true and which are false? Means you have to find out true or false, and also give reasons. Sorry, this reason spelling is wrong here. Okay. Give reasons for your answer. Okay, number 1. Only one line can pass through a single point. Is it correct? False. Why? If you are taking single point, suppose this is a point. Okay, so this line can pass through a point. Also, if you draw from this side, this line also can pass through this point. Also this side. Also like that. Means there are so many lines. How many lines you cannot count. So false, since in infinite number of lines. Infinite number of lines can be passes through a single point, means passes through a point. Understood? Next, there are infinite number of lines which pass through two distinct points. This second one means, suppose you are taking 2 points, this one, there are infinite number of lines which passes through two distinct points. Means if you want to draw like that lines, draw straight, you can use your scale. Okay, like that. You also draw. Already I told you this one axiom. Sorry. So like that. Only one line you can see. Only one straight line you will get, which is passed through both the point. Only one line. Maybe this figure is not so clear, but you understood, no? Because here one point, here one point you are taking. If you draw lines, only one line can pass through both the point. But according to the condition, there are infinitely number of lines which passes through two distinct points. So it is false, since through two distinct points only one line can pass. I'll already told you only one line can pass through. Understood? Okay. Next, question number 2. Okay, I want to tell you that there are 3 more questions, 3, 4, 5. So you can do yourself. Next, question number 2. Try to understand the question clearly. Give a definition for each of the following. You have to give definition. Understood? Give a definition of each of the following terms. Are there other terms find that need to be defined first? What are they and how might you define them? Means they have given some terms to explain or to write the definition. Before that, to define that terms what they have given, if you need to define some other points, then you can do. For example, suppose you are going to define straight line. To define straight line, first of all you have to know what? Line. You should have the knowledge of line, then only you can understand straight line. So like that. So now parallel line, there is a parallel line, then perpendicular line, line segment, radius of a circle, c square, these are. Okay, for that, these points already I have explained in the Euclid's definition, or you can find out. I am not going to give this definition here. Okay, so you can find out easily. Already I have given. If any confusion, you can ask me later. Okay, point. You know what is point? Point has no part. Line, you know. Line has what? Breadth length. Plane, you know. The smooth surface of a table also you can say plane. Ray means you know. This is called ray. This is the end point, and here you can extend it indefinitely. This is called what? Ray. Then angle, you know, this one, these 2 arms. Okay, this angle is, this is called what? Angle. Then circle, you know. Then quadrilateral also, you know. Clear? This point already you know. If any confusion, you can ask me. So I'm going to the main point, parallel line. You got already what is parallel line. Two lines are said to be parallel. Okay, two lines said to be parallel if they lie on the same plane, and they never intersect each other whenever extended independently. I am taking the example. Okay, these two lines. Okay, see, they lie on the same plane. First condition. Second, they never intersect. If you extend this side or this side or this from this side, they never intersect. Means they never touch like that. Only that type of line you can say parallel line. Here, L parallel to M. This is the parallel symbol. Understood? Perpendicular lines. If two lines intersect each other at 90 degree, then these are called perpendicular line. Means you can say like that. Here two lines M and L intersect at what? 90 degree. So L perpendicular to M. Or this is XY OM. This is 90 degree. So you can say that OM perpendicular to XY. Means two lines when intersect each other at 90 degree, they are called perpendicular lines. Line segment. Line segment you will already know. A line segment is a definite length. Suppose a line from this is line segment 5 centimeter. This is called also line centimeter 3 centimeter. Any which has length, that means for body length is called line 3 centimeter line centimeter. A straight line drawn from any point to any other point. See, from this point to this point, or sometimes from this point to this point, is called a line segment. Next, radius of a circle. See, radius of a circle, we can say that half of the diameter is called radius, but half of diameter is called radius, it is correct, but you are taking help of diameter to define radius, but directly you can explain what is radius. See, this is center, the constant distance from the center, from this one to this one, this is called what? Distance from center to the circle. This is the circle. Okay, this is the circle, from constant distance from this is the circle. Okay, so from this center to the circle is called, from this side also, these are called what? Radius. The constant distance from the center to the circle is called radius of a circle. Next is square. Square, you know, square is also is a quadrilateral. Actually, square is a parallelogram. Okay, square is also a quadrilateral because a polygon which has 4 sides is called what? Quadrilateral. So from quadrilateral you got parallelogram. So you can write a square is a parallelogram which has all the sides are equal. Means this is also a special type of parallelogram. In a square, you can, in a parallelogram what? Opposite sides are equal and parallel. But in a square what? It is also a parallelogram, but all the sides are what? Equal. And measure of each angle is what? 90. This is what? A square is a parallelogram which has all the sides are equal, which has all sides are equal, and measure of each angle is 90. Clear? All the definitions? Okay, next. Here, question number 3. Consider two postulates given below. Okay, two postulates they have given. It is from Euclid's postulates or not, that is I don't know. Let me read the question, then we will understand. Given any two distinct points A and B, two distinct points A and B, there exists a third point C which is in between A and B. Try to understand. There are two distinct points A and B, there exists a what? Third point what? C. Third point C which is lies between what? A and B. Means C is lies between A and B. Next second, there exists at least 3 points that are not on the same line. Means if you can say 3 points, they are not according to that question, according to the condition 2, there exists at least 3 points, minimum 3 points, that they are not, they should not lie on the line. So I want to say that please clear it. There exists, okay, minimum 3 points which are not on the same line. So now these two postulates they have given. Now question is what? Question is this: do these postulates contain any undefined terms? Okay, from these two conditions, did you understand clearly? Read once again and try to understand. Okay. So do these postulates contain any undefined terms? Are these postulates consistent? Do they flow from Euclid's postulates? See, here if you see given any two distinct points A and B, there exists a third point C which lies in between A and B, and there exists at least 3 points that are not on the same line. There are so many things to explain. Understood? They have not given clearly. That is why there are various undefined terms in the given postulate. So many undefined terms are here. Okay. Next, are these postulates consistent? The given postulates are consistent. Why? Because they refer to two different situations. They refer to two different situations. Also, it is impossible to deduce any statement that contradicts any well-known axiom and postulates. And those are like this, means those statements are from those statements we cannot deduce any statement which contradict any well-known axiom and postulates are consistent. Understood? So try to understand this clearly. That first they asked, do these postulates contain any undefined terms? We said yes. There are so many undefined terms. There are various undefined terms in the given postulates. Then asked, these postulates are these postulates consistent? The given postulate consistent. Why? Because they refer to different situations. They are both these postulates are what? Refer to different situations. Also, it is impossible. Why? Also, it is impossible to deduce any statement that contradicts any well-known axiom and postulates. Understood? Next, are these postulates, do they flow from Euclid's postulates? See, here you cannot say, because there are, you know already the Euclid's postulates, then they are not flowing Euclid's postulates. You can say clearly, because they are not from the Euclid's postulates. So, these postulates do not flow from Euclid's postulates. Okay, what they flow then? Little you can say they flow axiom 5.1. Why? Because there exist at least 3 points that are not on the same line. What? Given any two distinct points A and B, there exists a third point C which lies between A and B. They flow what? Axiom. Why I say they flow axiom 5.1. Why? Because that is axiom 5.1 is what? Given two distinct points. If you are taking two distinct points, there is a unique line. There is a unique line that passes through them. Understood? They flow this one, but then they do not flow Euclid's postulates. Understood all of you? Okay, next. Next question number 4. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half of AB. Means, suppose you are having 2 points A and B and C lies between such that what? AC is equal to BC. Means C should be midpoint. Then only it becomes AC is equal to what? BC. Then prove that AC is equal to half of AB. Explain by drawing the figure. Actually, I have drawn the figure. Means I have solved this question already. So you will understand. See, I have drawn AB is a line segment. Then C lies between there. Means C lies like that. AC is equal to BC. Means C is a midpoint. If C is a midpoint, now you have to prove AC is equal to what? Half of AB. Obviously, it is correct because C is the midpoint. Means what? BC is also equal to half of AB. AC is also equal to half of AB. But you need to prove it. So how to prove? We have AC is equal to BC. We are taking this one. AC is equal to BC. Now we have to add AC on both the sides. See, AC plus AC, BC also AC plus AC. Now you are thinking that what is this? This is according to axiom, Euclid's axiom, that if equals are added to equal, then whole are equal. Now here adding equal or not, AC also equal to AC and AC is also equal to BC. Means AC on the both sides. And also mathematically it is plans. Why? When you transfer this AC on the left hand side, this AC become minus, then plus AC minus AC cancel. It is mathematically plans. Or also using Euclid's postulate. Now AC plus AC what? Twice AC. And BC plus AC? BC plus what? AC. BC plus AC what? BC plus AC is what? AB. Now 2 is multiply with AC. If you transfer 2 on the right hand side, you will see it is divided. AB by 2 means what? Half. So half of AB. So you got AC is equal to what? Half of AB. Understood? What we have done first? AC equal to BC. Then adding AC on the both side. After that 2 AC. Then AB. Then AC. Then AB by 2. Then AC is equal to what? Half of AB. Next. In the above question, point C is called. In the above question, point C is called a midpoint of line segment AB. Prove that every line segment has one and only one midpoint. See this question. Okay. In this question, you can see C is the midpoint because this question is related with this question. Also C is midpoint. If C is midpoint, then what we got? AC is equal to what? Half of AB. Yes or no? And C is also called what? Midpoint. Then we need to prove that in this question C is called midpoint. Then AB is line segment or not? In this line segment, how many midpoint we will get? In this question we got C only. So we need to prove in a line segment only one midpoint is there. It is correct, because if we take one line segment, then how many midpoint you will get? One. For example, if you are taking a pen, how many midpoint you will get? This pen is not a suitable example. I can give you this stick. How many midpoint you will get? Only what? Only one midpoint you will get. Yes or no? Only one midpoint. This is a line segment, then one midpoint. You will not get two midpoint. Only one midpoint you will get. Yes or no? So like that, a line segment has only one. You need to prove it. Okay. Let us consider point C is a midpoint of a line segment AB. I am taking point C is a midpoint of line segment AB. Okay. Do you know? You're looking the. Okay, I'll explain about the. First, try to understand. Let us consider point C is a midpoint of AB. Okay. So if when C is a midpoint, what do you got? AC is half of AB. So when C is a midpoint, you can write here also. What you can write? AC equal half of AB. Don't forget, you need to prove one midpoint. A line segment has only one midpoint. Suppose this another midpoint of AC. I am taking this another. I know it is not possible, but I am taking. Okay, why I am taking? I'll explain later. I am taking this another midpoint. When C is a midpoint, then AC is equal to what? Half of AB. When D is a midpoint, then AD is equal to half of AB. Now AC is half of AB or AD is half of AB. If you compare on the both sides, or if you use axiom 1, what is axiom 1? That if AC is equal to half of AB and AD is equal to half of AB, then AC is equal to AD. This is the axiom 1. Axiom 1, AC is equal to half of AB and AD is also equal to half of AB. Means this is also equal of half of AB, and this means they are equal to the same thing. So they are also equal. Means AC is equal to AD. Or if you compare according to mathematics, comparing on the both side, what? AC also equal to half of AB, AD also is equal to half of AB, so AC is equal to AD. Now if you transfer AD this side, AC minus AD is what? You can write right hand side 0. And when it becomes in only there a condition that C and D when equivalent, means they are coincide, means where you can get C in the same point you will get D, means there is no 2 point, there is only a single midpoint. Okay, only that time you will get this one. So you get C and D are what? Coincide. When C and D are coincide, then only you will get AC minus AD is equal to what? 0. So C and D are coincide. And already you know from the axiom that those things are coincide, they are equal. So C and D are coincide means what? C and D are equal. If C and D are equal means what? There is only one midpoint, means C and D in one position only. So a line segment has only one midpoint. Understood all of you? This is your today's class. In the next class I am going to explain, or I am going to solve exercise 5.2. okay, so now see your homeworks. Exam 5.1, question number 1, 3, 4, 5. Sorry, exercise 5.1, question number 1, 3, 4, 5. This is true, false, and you have to write the reasons also. Question number 6 and 7. Do your homeworks, okay, and submit in the evening. And also from this explanation, what I explained, and also I have solved the exercise 5.1. If any doubt, okay, then you can clarify in the given time. Thank you so much.